And Sam will tell you how much of all those comments can you actually hear?
A lot, some.
Some?
Yeah,
I can
there
hear
are a
them.
lot of
I heard them a lot.
Okay.
Definitely do.
Not never quite sure. So yes, we're all about the roots today. But in the past, you've only been limited to square roots, maybe the occasional cube root. There's more to life in the land of roots than that. So we have to discover those. But I need to double check first here a couple things. All right, basic question. What's the square root of 25?
2.5.
Why is it 5?
5 times 5
What times itself makes 25? So why isn't negative 5 an answer? Because negative 5 times itself makes 25. Actually, negative 5 is an answer. But somewhere back in the deep dark past, mathematicians decided that when we do square roots, we're only going to give the positive answer. That's what they call the principal root. We're not going to give the negative answer. So we don't give the negative 5, but actually that is correct. But it's just plain old square root 5. And what if I asked you for the cubed root of negative 8? What does that mean when they put a 3 up there?
How many, what number of
What number multiplied 3 times by itself makes negative 8?
2.
Positive 2?
Negative 2.
So we say, if you take 2 times 2 times 2, do you get negative 8? You got to have negatives on all of them. So you can get a negative 2 as an answer. So on a cube root, or basically on an odd root, any root that's odd, cube root, fifth root, seventh root, you can have a negative inside, and you can get a negative answer. Now, what do we know happens if I ask you for a square root of a negative number?
That's positive. You have to like plus or minus. It's like almost like you can't do that. Doesn't it fall on the eye?
Thank you. You were worrying me. Yeah, that becomes 7i. Okay, but I is defined only with square roots. I is not defined with other roots. For our purposes right now, we are looking to work with only positive numbers inside square roots. We are not doing, you shouldn't see imaginaries in this section. So don't worry about that. But yeah, you can still get a 7i. Well, what if I asked you for, say, the fifth root of 243? Well, actually, you don't have to break out your calculator. You just have to break out your little pink piece of paper. Because what I've done there is I've given you the common powers of numbers. And so, if you're going to read this, you'll notice across the top you have x squared, x cubed, x to the fourth, x to the fifth. So in our case, if we're trying to do a fifth root, you would need to know go to the x to the fifth column and look and see if you can find 243. And you'll notice if you go across then it was 3 to the fifth power. So yes, the fifth root of 243 is 3. So that'll make it a little bit easier. Okay, before we make this more exciting, little terminology here. This is especially for the Scholars Bowl folk who sometimes get asked this stuff. Does anybody know the official name of what's inside a root? The radicand, yes. Okay. Anybody know the name of that little number up on the root that indicates starts with an I? It's the index. That's the index on the root. Technically, a square root has an index. Well, what index should be on a square root? 2. Because you're saying what times itself twice. So there really should be a 2 on square root. But mathematicians use that one so much they went, we're going to write the little 2 all the time. If there's no index on there, everybody knows it means square root. We're not going to put 2 on. But technically it is there. All right, let's do a little double checking here. What if I said to you, what is the cube root of negative 125? What would you tell me? Close.
25.
Positive 5 will not make it come out negative 125.
Negative 5.
It would be negative 5 times itself 3 times. Would make a negative 125. Well, let's go a little farther here. What did we do with square roots when I gave you something like square root of 24 that isn't a perfect square number? You pulled out a number that was a perfect square. So 24 we thought of as being what?
24.
We thought of 24 as 4 times 6. So we could take out the 4 would become a 2, and I was left inside the 6. And we got 2 times the square of 6. Well, the good news is now you can do it with cube roots and fourth roots and fifth roots and 10th roots and any other kind of roots. Yes, it is. So the thing is though, when you're trying to think of two numbers that multiply to make 40, you got to think of numbers that are cubed numbers. So if you look down your x cubed column on your pink sheet, looking at those numbers in the x cubed column, are there any that multiply to make 40? 8. Yeah. So we would think of 40 as being 8 times 5. The cube root of 8 is really 2 when you take it out. You would be left with 2 times the cube root of 5 then. So, you go, yeah, I didn't give you power to remember, but. So, what if I said, let's break down the fourth root of 162. You would go to your handy dandy pink sheet and go x to the fourth. What number goes into 162 evenly? Well, 16 clearly isn't going to work. Does 81 go in there? Yeah, 81 times 2 would be 162. Now, I got him this morning on this one. What do you get when you take out the 81?
9.
No, 3. You get 3.
Because you have to go what times itself 4 times makes 81. Not, because our habit is, we all know 9 squared, we want to pull a 9 out. But it is the fourth root, so it's 3 to the fourth is 81. You have to pull the 3 out, and you're left with a fourth root of 2 on the inside. Okay, beware of numbers like 81. Notice 64 is on that pink sheet 3 times. 64 is 8 squared, 4 cubed, and 2 is a 6. So 64 has a lot of different ways it can go.
So you have to stick with that number up at the top.
You have to stick with whatever the index is, yes. You got to stick with the index. Alright, one more. Here's a big mama for you. I want to do the sixth root of 3,645. I want to break that down. So you would look where on your little pink sheet? You would look into this x to the sixth column. You would look for a number that goes into 3,645. It's not going to be the 64, because 64 you can't make it into the 5. 729?
Yeah, 729.
729 times what?
5. 9.
Yeah, times 5.
9.
So then, okay, what comes out when you take 729 out? It is 3 to the 6th power. So therefore, you get a 3 on the outside and a 6 through the 5 on the inside. Isn't that nifty? We're having a good time with this. Oh, I'm not. I'm only 9. So, that's my biggest. Oh, okay. I actually think it's harder to do with numbers than it is with variables. Now we're going to do variables.
Really?
So how do you break down variables inside different kinds of roots? And once again, you all have the common sense behind this already. We just need to figure it out. What times itself, if I'm doing a square root here, what times itself makes a squared? Wouldn't it be a times a makes a squared? So I take it out and I get an a. Well, here's your wrinkle. Remember we said square roots have to come out with positive answers, actually even roots. Square roots, fourth roots, sixth roots, eighth roots, anything with an even root has to come out with a positive answer. Can you all guarantee me that that A right there represents a positive number?
No.
No.
Yes.
So I have to put something on it that'll force it to be positive. Absolute value. So you would have to absolute value that A to guarantee that it's going to be a positive number. So what if I asked you for the square root of A to the fourth?
A squared and
Yeah,
absolute value.
yeah, A squared times A squared makes A to the fourth, so yes. Now, do I need an absolute value on it?
No.
Why?
Because it's squared.
It's already squared. It's going to be positive. So since it's already got an even power on it, you won't have to worry about it. A squared is going to be positive. Alright, so here we go again. I'm looking for patterns here. What if I said what's the square root of y to the sixth?
Y to the third, and that's the values.
Okay, I got a y to the third and absolute value. Y'all buying that? Y to the what power times y to the what power would make 6?
Y to the third times y squared.
What do you do to powers when you multiply? You add them, so 3 plus 3. So this would become y cubed. Does it need an absolute value or not? If something's cubed, it could come out negative, because that's an odd power. You could, if that is a negative number, so yes, you would absolute value this way. Okay, does anybody see a shortcut to how we were doing that?
Whenever it's
On
the variable, and then.
Sam's saying I was always half the power.
If it's even, you don't need the absolute value.
If it's even, you don't need the absolute value, that's correct. Let me give you one more and see if you... Suppose I said, what's the fifth root of z to the 20th? So I'm saying z times itself 5 times, what power would have to be sitting on all those z's that it would add up to 20? Wouldn't they all have to be the fourth? So therefore my answer is z to the fourth. What's the easy way if you're looking at those two numbers?
20 divided by 5.
That's right, all you have to do is divide the index into the power and it tells you. 5 goes into 20 4 times, answer z to the fourth.
It's like magic.
Check. Up here, if you remember, square roots are really an index of 2. 2 divided by 2 would be first power. I go to the second problem, 4 divided by 2. So 6 divided by 2 is 3. All you're doing is dividing by the index. And you actually can break it down fairly easily.
Can you do another one, like a bigger one?
Yeah, we can. Let me wow and amaze you here.
Give us a hard one. You can try.
Suppose I said a to the 8th, b to the 28th, c to the 100th power.
Divide them all by 4,
A squared,
A
b to
squared.
the 7th, c to the 25th.
Alright? Y'all buy that? So you divide them all by 4.
Yeah.
Do any of them need absolute value?
The C and the B need to.
The b and the c came out odd. They're odd numbers.
Yeah.
So it doesn't matter. We want them to have to be positive. Now you may put them in one giant absolute value.
We can't do the other one. The absolute value separate them.
You could. It gets awfully messy and confusing.
But that's why I do it.
You want to be messy and confusing?
Just so you don't have to create it.
Thanks, Stephen. I really appreciate that.
Wow.
Okay, I'll show you when I don't appreciate it. Separate ones. Suppose your first one, the middle one was even, and your third one was odd. Then which ones need to be in absolute values?
The first and third.
The first and the third. Can you tell me what's in absolute values if I do that?
Yes, all of them.
No,
That
A
does not
and
work.
C.
If that happened, you should put the b to the fourth alone, and then put the a's and the c's all in one, so you can tell what's really in the absolute value.
20 seconds.
Oh, whoa. You are right. Thanks. Okay.
What are you talking about?
That is a good place to pause for a moment. This is a station break.
Stop looking.